Good day everyone. Today we were going to tackle chapter 13, the feedwater loop, from the book of Frederick T. Morse, Power Plant Engineering. So, function of the water loop, the conversion of condensate into a hot boiler fed at a pressure sufficiently above that of the boiler to cause the correct flow into the boiler that is correct from the standpoint of fed water demand under variable load operation. So the technical problems of design and operation of this phase of steam plant engineering are conveniently grouped under. So we have three. So the first is the water treatment. So what is water treatment? So water treatment, water quality, and operating difficulties originating in inferior water remedies and preventive treatment. So next is water heating. The reason for heating has been alluded to previously in this volume. And the last one is the water pressuring and regulation, which is the pumps and fed water regulators. So the heating of boiler-fed water introduces threefold benefits into plant operation. So there are three advantages. So this figure shows that the equipment of the water loop. So these are the equipment of all of these are comprising the equipment of the water loop. So the benefits or the advantages of the heating of boiler-fed water is first, heat which would otherwise be wasted if diverted into feed water represent fuel savings. So we can save fuels. So second, thermal stress which can be induced in boiler surfaces by impingement of cold water streams is minimized. So heating feed water increases the steaming capacity per square meter of installed boiler capacity. So these three are the benefits of the heating of boiler feed water. So next is the water contamination. So what is water contamination? So natural waters usually contain dissolved salts and gases. So that is the composition of the natural waters. So, and some organic and inorganic material in suspension. Dissolved salts are carbonates, sulfates, and chlorides of calcium, sodium, and magnesium, and occasionally some iron, aluminum, or silica salts. When the impurities find their way into the water of a boiler, they remain there until. So, those contaminants are um, constant until they are neutralized by some intentionally produced internal chemical reaction. Next, they are removed by boiler water blowdown, or they produce operating difficulties which is continued unabated may finally lead to disuse of boiler or the explosion. So this figure shows the some sources of impurities in groundwater. So next is the scaling. Scaling is primarily scaling results from the decrease of solubility of some salts with increase of temperature. So that is what when we talk about scaling. So scale due mainly to salts of calcium and magnesium, and to a lesser extent to silicate. So calcium is the principal offender, particularly calcium sulfate, calcium and magnesium. Magnesium bicarbonates are broken down by moderate heating, so 100 degrees Celsius, into relative insoluble monocarbonate and carbon dioxide. The reactions are this. This is the reaction. So magnesium sulfate is fairly soluble in hot water, and chlorides are usually sufficiently soluble not to be troublesome. Sodium salts are highly soluble in hot water, that not only are they non-scale forming, but some chemical treatments intentionally replace calcium and magnesium with and sodium, but unfortunately, calcium sulfate has solubility varying from 3,200 ppm in 15.6 degrees Celsius water to 55 ppm and 227 degrees Celsius and 27 ppm at 316 degrees Celsius. So, corrosion. So what is corrosion? So destructive conversion of metal into oxides or salts. So corrosion in our language is, or in our dialect is attack. So corrosion is due to an acid condition of water or oxygen, carbon dioxide, or chlorides. So oxygen corrosion occurs typically as small pits and depressions, often covered with crust or scab of black. So FE sub 304 boiler operators who have been treating fed water for absolute prevention of scale sometimes protect against corrosion by applying protective coatings. So in order to prevent corrosion, some applies protective coatings to internal surfaces of boilers and economizers. So foaming and priming. So foaming refers to the condition of boiler operation where a stable foam is produced. So priming, which is the production of wet steam, or in the aggravated case, slugs of water. Foaming is the most common source of carryover on boilers equipped with drum internals. So tests have sometimes revealed foam blankets of 305 millimeters or more thickness above the drum water level. So the table 13-1 shows the factors affecting carryover. So all of these are the factors affecting carryover. So embrittlement. So what is embrittlement? So this is the rarest or hard to find or hard to see all boilers diseases. So it's like uncommon. So it cannot be said to be so rare as to be unimportant. It is attributed to be present of certain concentration of sodium hydroxide in the absence of inhibiting agencies. So the figure 13-5 shows the embrittlement detector patented courtesy power. So water test and analysis. What it is? So an assortment of devices to heat, pressurize, and regulate the flow of liquid water. So the purity working fluid extreme importance to the safety of life of steam generators. So the water involved may be, so we have five. First, boiler water, actual liquid contents of boiler of which in the water drum typical. Next is the blowdown water is drained from the boiler depending on the point of blowdown. Next is our fed water, the water which is introduced into the boiler to replace the evaporation. 4 is raw water, natural water with such impurities like we tackled earlier as the earth has originally endowed it. 5 is the makeup of losses, may be raw water or treated low water. So groundwater, wells and spring. So has picked up dissolved hardness in seeping through rock strata but is usually clear. So surface water, streams and lakes. So the examples are the streams and lakes has pick up dissolved hardness and insoluble organic and inorganic matter in suspension. According it is turbid, in general, natural waters need softening for the removal of dissolved solids and sometimes clarification for the removal of turbidity. So tests can be expected to supply pertinent information on such important items as variation in mineral characteristics of raw water supply, percentage of condensate in makeup in the fed water, efficiency of condition of the boiler water with respect to the treatment adjustment, condition of the boiler water with respect to blowdown adjustment, correction of fed water and boiler water for corrosion control, steam purity, return line corrosion, condenser leakage, and contamination of returns from process units. So hardness. Hardness is due to dissolved salt which make it difficult to obtain soap suds in the water. So hardness H as CaCO3. is equals to S minus S sub 0 times 1000 divided by ml of sample ppm. So type of hardness, we have temporary hardness, can be removed by heating or boiling point, also called as carbonate hardness. So permanent hardness, water containing salt which precipitated only at higher temperatures. So next is alkalinity or alkaline, is the condition of predominance of OH ions over H plus in solution. So alkalinity is the condition of predominance. So yes. So table 3-2 shows the alkalinity relations. So dissolve oxygen or O2 and carbon dioxide. These two corrosion accelerators are detected and quantitatively measured by a chemical titration routine wherein the quantity of titrating reagents is used to determine the dissolved gases in ppm. So dissolved solids. So primary gravimetric tests for dissolved solids involve time and equipment requirements that place the methods outside of scope of routine boiler water testing. So the table 13-3 shows the maximum boiler water concentrations recommended by American Boiler Manufacturers Association. So next is the complete water test. So natural or raw water is the supply most frequently subjected to a full analysis. On the account of ionization, it is impossible to determine by analysis of water the nature of each compound that was dissolved in it. So the next table shows the properties of common ions. So these are the properties of common ions. So next is the concentration, or also known as blowdown. What is it? So in plants using raw water or chemically treated water for makeup, there is a steady accumulation of dissolved solids in the boiler water. So control concentration is obtained by two methods, both involving draining off some of the concentrated boiler water. First is the periodic manual blow-off, employed in smaller plants and where ppm of solids in fed water is low. So next is the continuous flow, the concentration usually accompanied by heat saving. So next is the every boiler must have manually operated blow-off valve connected to the mud ring or mud drum. So the figure shows is the boiler water the concentration. So we have here the fed water called blowdown, make up meter, flow regulator, and the boiler, guard valve, and the blow off valve. So that's consists the boiler water the concentration. Next is this is also schematically illustrated. Symbols on the diagrams are defined as follows. So these are the what do you call the symbols which has um these figures is talking about. So all of these. So next would be the manual blow-off system is an essential boiler attachment. It must be installed even if continuous blowdown is practiced. So continuous blowdown equipment is installed only if justified on the basis of heat recovery or some tangible advantage to boiler operations. By development from equation 13-3, we can say that the due to heat recovered from the continuous blowdown is so annual saving is equal to 0.001 kW sub S times C times S sub T times delta HT over S sub B by minus S sub T times dollar, where kW sub S is equal to estimated annual evaporation, thousands of kilograms. C is the dollar value of 10 raised to 6 joules in the fed water, and H delta HT is equals heat saved per joules kilogram between T sub I and T sub O.